So in this video we are going to discuss some very simple graphs using calculus. So say that the first graph that we have been given to plot is y equals to x squared. So let us plot that graph here. If I take the derivative of y, I get 2x. I can see that y will always be positive for either x negative or x positive. Y will always be positive. So first let us focus on the positive values of x. At x equals to 0, y equals to 0, so the graph passes through this point, and at x equals to 0 the slope is 0, and since the slope is 0, so at x equals to 0 my y is 0 and my dy by dx is also 0, which means the slope at the origin is 0. So the graph will start in somewhat in a manner like this, so that at the origin, if I draw the slope, I get the angle to be 0, and tan theta will therefore become 0. We can also see that as x increases, y increases. Also from here we can see that as x increases, the slope also increases. So the graph becomes somewhat like so. So as we keep increasing x, obviously y is increasing, but also the slope is increasing. So the slope keeps on increasing as we keep increasing x. For the negative part of x, we can see that whatever positive value of x we may have, for the same negative value of x, we'll have the same y. So the graph will be symmetric about the y-axis. So it will be somewhat like this. So that is the graph of y equal to x squared. Let us now draw the graph of y equals to square root of x. If we draw the graph of square root of x, if we first differentiate y, dy by dx will be 1 by twice the square root of x. So at x equals to 0, now we again have y equals to 0, and dy by dx tends to infinity. Anything divided by 0 will go to infinity. So in this case we can see that again the graph will pass through this point, because at x equals to 0, y equals to 0. Also, what will be the slope at the origin? At the origin, the slope goes to infinity. So tan inverse of infinity means 90 degrees. So the graph will start somewhat like this. Also, we can see that as x increases, my slope keeps on decreasing. So the graph begins like this at an angle of 90 degree at the origin, because the slope at the origin is 90 degree, or the derivative is infinite, and the graph goes something like this. So we can see here that as x increases, my slope keeps on decreasing, as indicated by this equation. We can also find graphs for, say, y equals to, let's say, 4x squared, or anything multiplied by with x squared. So here we can say that from the previous graph, every value of y that we had before will be multiplied by 4 for the same value of x. So let me draw the this graph here itself. It will become somewhat like this. So for this x, if I had this much y before, I will now have 4 times as much y. Also, here my dy by dx is 8x. So my slope also becomes 4 times than what the slope was before. So my slope at this x, if it was this, now it has increased 4 times. So not only does my y become 4 times, my slope also becomes 4 times. We can also figure out what the graph of, say, y equals to x squared some number, x squared minus some number, let's call that 6, will be. That will basically retain the same nature as this graph, but for every x my y will be shifted 6 units below. So it will be something like, let us say it will be something like this. It is this same graph which has been shifted 6 units below. Let us now figure out what the graph of y equals to e to the power of x will be. So at x equals to 0, my y will be equals to 1, because for x equals to 0, y is e to the power 0 and anything to the power 0 is 1. We can also see that y is always positive and y also increases with increasing x. Let us see what the slope of dy by dx is. Sorry, what the slope of y is. The slope of y is dy by dx, which is the same, e to the power of x. The slope being positive, that also tells me that y is an increasing function. And at the origin, that is at x equals to 0, y is equals to 1. And at x equals to 0, let us see what my dy by dx will be. It will be 1. So at x equals to 0, not only is the value of my function 1, my slope is also 1, or my dy by dx is 1. Therefore, the graph at this particular point will go at an angle of 45 degree. It will go in a way like this. We can also say that for negative infinity, if my x decreases, continuously decreasing, y goes to 0, and for x going to positive infinity, my y also goes to positive infinity. So my graph will be something like so. So with increasing x, my y increases. With increasing x, my slope also increases. At the origin, the value of my y is 1. At the origin, the slope is also 1. So at the origin, the graph or the tangent drawn to the graph at the origin makes an angle of 45 degrees. And for negative x, if x becomes negative, my as x approaches negative infinity, y approaches 0. So one final example, let us try to find out what the graph of e to the power of minus x will be. In the same way, dy over dx will be minus of e to the power of minus x, and at x equals to 0, y will again be equal to 1, but here as x approaches positive infinity, my y will approach 0, and as x approaches negative infinity, my y will approach positive infinity, and at x equals to 0, my slope will be -1. So the tangent drawn to the graph at the origin will make an angle 135 degree with the positive x-axis. So my graph will become something like this. So this will be the graph of e to the power of -x. As x approaches infinity, y approaches 0. As x approaches negative infinity, y approaches positive infinity, and at x equals to 0, y is 1. Also, the slope is, I'm sorry, I should have written -1 here. The slope is -1. So a tangent drawn at this particular point will make an angle 135 degree with the x-axis. So these are some basic simple graphs that we can draw with using calculus.